Hello everyone and welcome to this video lecture. I am Panayota Katsikouli and I will be your instructor for this course. This week we will talk about the various working environments in Python and the ones that you will be using in this course. In this video we will talk about Python as a choice for data analysis. In particular, I will start by giving a brief history of Python. Afterwards, I will outline some basic differences between interpreted and compiled programming languages so that it is easier to understand and appreciate why Python is suitable for a lot of applications, but also when to avoid it. I will conclude this video by presenting various tools of Python for data science, some of which we will explore together later in this course. Python was conceived in 1981 by Guido van Rossum. It was a project that he engaged with during his Christmas holidays. The idea was to create a scripting interpreter language, which would be easy to program, easy to learn, readable, and eventually open source. Needless to say that he succeeded in his task. Since Python's first publication in the 90s, it has grown to be one of the most popular programming languages today. Recent statistics from job postings in LinkedIn show that indeed Python is the most in-demand programming language in US and the second most in demand in Europe. We mentioned that Python is an interpreter language. That means that the source code is read and run line by line, and that the code statements are converted one by one into machine code by the interpreter. In general, interpreted code runs slower than compiled code. In compiled languages, the entire program is read and run, meaning that the source code is transformed into machine code at once by the compiler. Compiled code runs typically faster than interpreted code. There are, of course, many more differences, advantages, and disadvantages between interpreted and compiled programming languages, but discussing this further is beyond the scope of this course. For now, it suffices to know that Python is an interpreted language, that the source code is read line by line, statement by statement, and that it generally runs slower than compiled code. But what is it then that makes Python so strong and popular? For one, around Python exists a large and active scientific computing and data analysis community. Python programmers continuously offer and always find help. Aligning with the language's philosophy to be open source, there exists a rich repository of open source Python code, as well as constantly updated libraries which automate certain functionalities. Python is indeed one of the most important and seeked languages for applications in the fields of data science, machine learning, and general software development, both in academia and industry. Python offers many and improved open source libraries that automate a lot of functionalities required in data science or machine learning. Furthermore, Python has an almost innate overall strength for general purpose software engineering. We won't discuss the details of this, but I encourage you to start by reading The Zen of Python if you're interested in learning more about the language's philosophy. Lastly, Python enables the integration of code from other languages, making it thus a valuable tool. There are, however, a few uses for which Python is not recommended. As it is the case with any programming language, none is equally good for all types of applications. For Python in particular, and exactly because the code runs generally slower compared to code coming from compiler languages such as Java or C++, the language it is not well suited for applications where CPU time is important. It is also not well suited for multi-threaded applications. Even though there are nowadays extensions such as Python C that allow code to run in parallel. In this course, Python will be presented for data science applications, as data science is a field for which actually the language is well suited for. This is supported by the many useful tools that Python has for data analysis. One such tool is NumPy for numerical analysis, which offers support for fast and efficient multidimensional arrays and array-specific operations. It also contains a lot of libraries for linear algebra. We will explore NumPy in week 8. Another popular and very powerful tool is Pandas, which offers data structures and functions for working with structured data, which is very useful for data analysis. We will explore Pandas in week 10. Matplotlib is perhaps the most popular tool for visualizing data. We will learn how to use it in week 11. The library scikit-learn is a toolkit for performing general-purpose machine learning with Python. We will take a look at this library in week 12. There are, of course, several more tools and libraries in Python for machine learning applications, such as is TensorFlow or Keras. Python also has a strong support for human language processing applications. Libraries such as NLTK and spaCy offer basic and more complex functionalities for this type of applications. We will not be visiting these libraries or these applications in this course. To conclude this video, let us review the highlights of this lesson. We talked about Python's conception in 1981 as a simple, readable interpreter language. Python is today one of the most important general-purpose programming languages, both for industry and research. Its popularity and strength stems, among other things, from the fact that it contains and supports numerous libraries for various scientific applications. It is, however, not suitable for multi-threaded applications or when CPU time is important. In the following weeks, we will explore a number of Python tools for data analysis, such as the NumPy library, Pandas, Matplotlib, etc. I hope you have enjoyed this video. See you soon for the next lesson in the Working Environments module.